Hi, I'm Assam, the lecturer here at the Institute of Medical Education, and today we're going to take a look at solutions to Section 3 of ACER's GAMSAT Pink Booklet, Practice Test 3, specifically Unit 28, questions 76 to 78. And in this unit, we're going to take a look at some sugars. We've been given it's a pretty, you know what, I like this unit stimulus because it gets straight to the point. It gives you some key rules to how to name monosaccharides and how to differentiate between aldoses and ketoses. So there's a few rules we have to take note. The first one is that sugar monosaccharides are classified by the number of carbon atoms they contain. So for example, if you have 5 carbon atoms, 1, 2, 3, 4, 5, it's a pentose. The prefixes aldo and keto. So you would have probably seen in previous videos how we go through aldehydes and ketones. Obviously correspond to the aldehyde or ketone functional group in the structure. So I've got an example here with an aldopentose and a ketopentose. So here it is. And finally, now is also the time to brush up on your stereochemistry, but it is pretty straightforward here. So in the exam, I think the best thing to do here would to just draw a aldo and a keto form of a specific sugar and use that as a yardstick for all the questions. Because you don't want to muck around, because they do give you an aldo tetrose and a keto hexose as examples. They're being a bit cheeky because they should have given you an aldo tetrose and a keto tetrose. Because what we're trying to do is we're trying to compare the monosaccharides with the same number of carbon atoms, but with a different functional group, whether it's an aldehyde or a ketone. Remember, aldehydes, they are bound to one carbon or one R group, and the other group has to be a hydrogen. I mean, the R group could be a hydrogen to a hydrogen for aldehyde, or pretty much it just has to have a hydrogen and an R group. Whereas the keto or the ketone group, so we see here, so this carbon has to be bound to 2 R groups, which are carbons. So that's one important thing to note. But when we draw these monosaccharides, it's going to be the same terminal structure all the time. If it's going to be an aldehyde, it has to be a terminal aldehyde here with your proton and your carbonyl group up here, and it's bound to, I guess, the aliphatic chain here, so to the sugar chain, whereas the ketone group has to be, I guess, one carbon away from the terminal carbon, because remember, ketones have to be bound to 2 carbons. So that's why it's always going to be 1 from the terminal carbon. It doesn't matter how long this chain is. If it was a ketopentose, it always has to be on the terminal end. Same with the aldopentose. So that's one thing to remember. So it doesn't matter if it's an aldotetrose or ketotetrose or a aldohexose or ketohexose. They're always going to be in the same position. So keep that in mind. So now with our rules that we have now under our belt, let's go answer question 76. It says, consider the structure of the following molecule. Which of the following best describes this monosaccharide? So if we count this molecule, we have, I've drawn it here, I've been a bit cheeky, so we've got 1, 2, 3, 4, 5 carbons, which means straight away we know it's going to be a pentose. And we have to find out, okay, so we've got our terminal group here. So we see it's bound to 1 carbon and a hydrogen, so it's an aldopentose. And now what it's asking is, so we can cross off C and D because we know it's not going to be ketone. Does it have 3 or 4 stereocenters? Let's count. So this can't be a stereocenter because it doesn't have, remember, stereocenters have to have a carbon bound to 4 different groups. So over here we have a carbon bound to 1, 2, 3, 4. So yes, that's a stereocenter. So 1, 2, 3, 4. Yes, that's a stereocenter. So 1, 2, 3, 4. Yes, that's a stereocenter. This can't be a stereocenter because it's bound to 2 hydrogens. So it has 3 stereocenters. The answer for 76 has to be A. So you had to use a couple of the rules here for the name, whether it's aldehyde or ketone, and the stereocenters. So now if we move on to question 77, it asks, consider the two monosaccharides with the same number of carbon atoms. One contains an aldehyde and the other contains a ketone. which of the following best describes these monosaccharides? So they've kind of given you examples. So to save time, just use the examples they've given you before. So we'll stick with our aldopentose. Now let's just draw our ketopentose. So remember what we said at the beginning. The terminal groups don't change. The length of the aliphatic chain or the sugar might change, but whether it's going to be an aldehyde or ketone, this terminal group doesn't change. So if we draw the keto group of a pentose, we end up with this structure. And if we read the question, it says, which of the following best describes the monosaccharides? It's asking about stereocenters. So we calculated earlier that aldopentose has 3 stereocenters. So the ketopentose, so let's do it again. So structure, this isn't chiral because it's got 2, it's not chiral, it doesn't have a stereocenter because it's got 2 hydrogens. It has to have 4 independent groups, remember. This only has 3 groups attached. This is going to be a stereocenter. This will be a stereocenter. This has 2 hydrogens, so not a stereocenter. So 2. So what we know is that the aldopentose or the aldo sugar group has 1 stereocenter more than the keto sugar group. So if we read the questions, or the options available in 77, A says the aldose will have the same number of stereocenters as the ketose. Incorrect. B says the aldose will have 1 more stereocenter than the ketose. Well, that's correct, so we can tick that. Let's just go through the others anyway. C says the aldose will have 2 more stereocenters than the ketose. Nope, we know it's 1. The last one says the difference in number of stereocenters depends on the particular aldose and ketose. And we know that's wrong. Remember, no matter how long this chain is, it can be as long as this. That doesn't matter because the ketose and the aldose groups are always going to be on the terminal end of the structure. So it doesn't matter how long the structure is. So that's why the answer for 77 is B. Now if we move over to our last question, 78, it says consider the number of carbon atoms in an aldose and a ketose and the number of stereocenters in each. The number of stereocenters are, the great thing about these questions is they're all related. So you can use the same examples as the previous. So I think ACER here, what they wanted to see is if you just knew what the rules were, how you can apply them. And if you could apply the rules, they wanted to pay you the mark, pretty much. They wanted to give you the mark because you put the effort in to understand the chemistry and to utilize the rules. So remember what we said. Aldopentose is going to have 3 stereocenters. Ketopentose has 2 stereocenters. So it says the number of stereocenters in the, if we see A, says aldose would be 1 fewer than the number of carbon atoms. So we're looking at now, the amount of stereocenters to carbon atoms. So aldopentose has 5 carbons. Ketopentose has 5 carbons. So remember 3 stereocenters, 2 stereocenters. So it says aldose will be 1 fewer. So the stereocenters will be 1 fewer than the number of carbon atoms. Nope. So aldose is 2 fewer. So that's incorrect. Aldose will be 3 fewer than the number of carbon atoms. Nope. It's 2. It's not 3, and it's not 1. So they're a bit cheeky here as well. So they've put 1 and 3, but not 2. C says the ketose will be 2 fewer than the number of carbon atoms. Nope, it's 3. So we're going to go down the list again. Ketose will be 3 fewer than the number of carbon atoms. Yes, that's correct. So with this unit, ACER pretty much wanted to see if you could utilize the rules provided. If you knew a thing or two about stereocenters, what's an aldehyde, what's a ketone, how do you draw structures, and if you understood much about, sugars and I think with this one, again, I think in previous videos I've said this before, if you want to improve your chemistry, I would read chemical names and draw them and try to draw them quickly and just find a whole bunch of chemicals, draw them, go on Google, see if you drew them correctly and understand the rules behind drawing chemicals and the rules behind why chemicals are this sort of certain structure. If you're still having difficulty with this unit, you can post your comments or queries in the comment section below, or you can contact us directly. We'd love to help. Thanks for your time. Bye now.